In this video, I'm going to explain how to perform image segmentation using deep learning models that were built using the BaseUNET architecture. Here I'm starting by showing how effective UNET models can be at classifying pixels in an image. But before I go into detail about how to use UNET models, let's familiarize ourselves with some features of the architecture. BaseUNET performs semantic segmentation. That is, it assigns class labels to each pixel within an image. UNET is capable of assigning pixels into multiple classes. UNET can be used to segment arbitrarily large images by implementing an overlapping tile strategy. And UNET works with very few training images to yield precise segmentation. UNET was designed by Olaf Runeberger and colleagues at the University of Freiburg. Now let's return to imagepro. Open the Deep Learning Prediction panel by clicking on the AI button on the Count Size ribbon. The Deep Learning Prediction panel loads on the right of the application. The panel is organized into 5 simple steps. In step 1, click the Load button to access the Open Model dialog and choose a UNET model. In step 2, you configure the names and appearance of each class that your UNET model finds. In step 3, select the target channel for segmentation. As this model was trained to classify pixels in color images, only color is available. You'll see a choice of channels for models trained with monochrome images. Step 4 is not used for BaseUNET models. This step is populated with configurable options for other architectures. In step 5, you count. I can illustrate how BaseUNET models perform semantic segmentation with this model that's been trained to assign pixels into 3 classes. A background class in green, a red blood cell class in blue, and an erythroblast class, that's a type of white blood cell, in red. Note that a BaseUNET model attempts to determine the correct class of each pixel in the image. It makes no attempt to identify individual objects. In images such as this one, in which each object is well separated from its neighbours, you do succeed in segmenting individual objects. In images where objects touch or overlap, individual objects are not found, but you can apply either manual or automated splits if measuring individual objects is important to you. The important point to remember is that BaseUNET is excellent at assigning all of the pixels in an image into multiple classes, but that it makes no attempt to automatically find individual objects. If you fail to adequately segment your objects of interest, you can consider improving your model with further training, and I refer you to our video on training BaseUNET models. Alternatively, you could load a different model, possibly based on a different architecture. Keep in mind that only BaseUNET is capable of assigning pixels into multiple classes. Thanks for watching this video. If you have any questions, contact Cybernetics and we'll be happy to help.